All right, our objective is to be able to solve and identify equations that have solutions that are either where the x value, the variable we're looking for, is equal to 0, where there's absolutely no solution to the equation, meaning that no variable that we put in no number that we put in for the variable will make the right side of the equation equal the left side of the equation, and then all real number solutions, meaning that we can select any variable, any value to put in for the variable, and it would make the right side of the equation equal to the left side. So let's look at a specific example of each of those. So if we look at our first example here, 3 plus x is equal to 3 minus 4x. And so what we see to start off with here is just an equation that has variables on both sides, which is a type of equation that we've already discussed. And so what we're going to do is we're going to move all the variable to one side, all the constant to the other side. And so I'm going to start with this minus 4x, and I'm going to add 4x to both sides. And what will happen is that we'll cancel out the negative 4x and positive 4x, inverse operations there, leaving me with the 3 on the right side. And then over here on the left side, we're going to drop down this constant of 3, and then add together the 1x plus the 4x to get 5x. And so now what we have created at this point is a two-step equation, which we've talked about before. And so I'm going to take and look at this 3 that is positive, and I'm going to subtract 3 from both sides. And what's going to happen is this constant is going to cancel out. It's going to leave me with 5x. But then what's going to happen over here is that this constant is also going to cancel out, and it's going to leave me with 0. And so now when I go to do this one-step equation, and I identify that I need to isolate the variable x and move the 5 and the x are connected through multiplication, I'm going to take and divide both sides by 5 and get an answer of x equals 0. And so, like all of our equations, we can do a check. And so if I go back to the original equation, 3 plus, I believe x is 0, is equal to 3 minus 4 times x is 0. Over here on this side, the left side, 3 plus 0 is going to be 3. On the right side, 3 minus, I got to do my multiplication first, 4 times 0 is 0. I can see that the right side of the equation equals the left side of the equation. And so my answer checks. And my solution to this equation is x equals 0. Let's look at a different example. Our next one here is 1 minus 5x equals negative 5x minus 5. And so once again, when we look at this one, we are starting with an equation with variables on both sides. A type of equation we've previously talked about. And so I'm going to select one of those variables and move them to the other side. And so what happens is if I take this negative 5x and I add 5x, what I do to one side, I must do to the other side. What happens on this side is the variables cancel out, and I'm going to be left with a negative 5. I need to be careful right here that I look at this constant of 5 and I take the sign that's in front of it. And so that's a negative 5. And then what happens over here on the left side is that these variables cancel out. And right there is kind of like my aha moment. If I look at this and I now see that variables on both sides of the equal side cancel out, I know that I'm going to have a special type of answer here. And that special type of answer is going to kind of depend on what's left in the problem. what's left in the problem is that over here on this side, there's a positive 1. And so what I end up with my constants is 1 equals negative 5. Well, I know that that is not true. And therefore, what my answer to this equation is that there is no solution. What no solution means is that there is no value. I mean, we could pick positive, negative, fractions, decimals, anything that will make the right side of the equation equal the left side of the equation. Meaning that no matter what type of answer or what type of number we tried to put in for x, our check would never work. Now the big thing is that we need to notice that that happened because if we look at our beginning problem, if I write that back out for us, our beginning problem for number 2 was 1 minus 5x equals negative 5x minus 5. What you might notice now is there was a negative 5x on the left side of the equal sign and a negative 5x on the right side of the equal sign. And when we went to move them, they canceled each other out. And what left us with that no solution was that our constants of 1 and negative 5 were not equal to each other. Let's take a look at another example. Okay, so for number 3, we're going to have 2 times the quantity x plus 4 minus 5 equals 2x plus 3. So it looks like a regular multi-step equation, variables on both sides. So we're going to start with that. And I'm going to have to take first and do the distributive property. So 2 times x, 2x. 2 times 4 is 8. I have to be careful that the 5 is not part of the distributive property. So I'm going to drop that down. And the 2x plus 3, I can't do anything with this. There's no distributive property or no combining like terms, so I'm just going to write that down. But then what I do notice here is that after I did the distributive property, in that first step, I can take and combine like terms here. And so I'm going to drop down the 2x, and then I'm going to have to combine a negative 8 and a positive 5. Now, at this point, you might notice something, or you might not. We're going to pretend that you don't, and we keep going on, because what we see right now is an equation with variables on both sides. If we were to take and subtract 2x from both sides, what would happen is the variable on the right, 2x minus 2x, is going to cancel out, and that constant of positive 3 is going to drop down. And then over here, the 2x minus 2x is going to cancel out. So right there we see that our variables on both sides are canceling out. And that's kind of our red flag. Hey, special type of equation coming here. What type of equation is that? When we drop down that last constant, we now have something that is true. 3 does equal 3. What we say then, our conclusion for this, is that our solution to this equation is that all real numbers are possible solutions. What that means is that if we would go around and I ask every single person, what value do you want me to put in for x? And everyone selected a different number, it would make the right side of the equation equal the left side of the equation. No matter if it was 0, a positive, a negative, a decimal, a fraction. We can plug any single number back in here for x, and that right side of the equation would equal the left side of the equation. So we want to make sure that we look for these three special types of equations when we're doing our problems. Notice that at the beginning they don't look any different than the equations we've dealt with before. So we do just have to wait till we get to that very last step to see if those variables cancel out. And if they do, are we left with something that is true, which gives us an all real numbers, or if we're left with something that is false, that gives us no solution. And we might be able to tell when we get so much through to the problem. So if we were to look at a problem that looked like this, let's say you work through a problem and you are at the point where you are at 5x plus 4 is equal to 5x minus 9. Well, you might be able to look at that problem and identify that those variables are the same, but the constants are different, and therefore this particular problem would have no solution. You might work through several steps of a problem to get to a point where you have 2x plus 6 equals 2x plus 6. And you could look at that and say, well, I know that these variables are the same and these constants are the same, and therefore the solution is all real numbers. Anytime that the variables are different on the right side or the left side of the equation, we're going to have to continue on and actually get that numerical answer, whether it's x equals 0 or something else.